Good morning to everyone. We're going to start today's session. In today's session, we're going to start with Smart Data Access. What is Smart Data Access? Now we know in data provisioning, we have different data provisioning methods, like we have SLT, BODS, DXC, and Smart Data Access. So we know the use of SLT for real time. When you require data in real time from source to target, and whether this could be a SAP or a non-SAP system. The source can be SAP or a non-SAP system. To get data in real time, we use SLT. BODS is rich in transformation of data. Batch process. It's batch, rich in transformation. DXC. DXC is used to get data in a sidecar scenario to bypass the existing BW and get data to HANA. Smart Data Access. This is used to get data from non-SAP systems. Smart Data Access cannot be used for SAP, cannot be used to connect to ABAP application server. It is used to connect to databases. So you can get connected to MS SQL, Sybase, get connected to Hadoop using an ODBC connection. These are different source systems, non-SAP source systems. And then you can get data from these systems via Smart Data Access. To HANA to create a data warehousing solution. So based on the Smart Data Access, we can create data warehousing solution. And so you can get data from heterogeneous source systems. You can get data from heterogeneous. Not only HANA is a database, it enables us to get data from different source systems and to create data models based on different source systems. In order to create Smart Data Access, it is just a connection. So I log into the HANA system. Log on to the HANA system. Just click Start All Program, SAP HANA, HANA Studio. Double click on the system. And click OK. So the provisioning, we see there is a folder called provisioning. Expand this folder. So here we see Smart Data Access. Right click on the remote source and click new remote source. Right click and click new remote source. Once you click new remote source, here you can see adapter name. If you expand the adapter name, so here you can see these are the supported adapters for the source systems like ASC, Teradata, IQ, HANA, Hadoop, Generic, Oracle, MS SQL, Netezza, DB2, MaxDB, Hadoop, Spark SQL, MII. So these are all the supported databases for now, and this list keeps on increasing release by release. Yesterday only HANA SP12 is released in the market. So by every service pack, SAP supports few more sources. So let us check any of the source system, which source system you want to connect. You can connect to MS SQL. You can connect to HANA. From HANA to one HANA system, you can connect to another HANA system, where you can keep actually use HANA systems as data mart solutions. Now, once this connection is established, once we establish the connection to the source, using an ODBC connection, now we need to create at the end we need to create a view. Information views of type calculation views are supported for smart data access of type calculation views. So these views, they get data from catalog. They get data from catalog. Under the catalog, we have different ways the tables can access data. Some tables are column tables. Some tables are row tables. Some tables are known as history tables. Some tables are known as virtual tables. So they are different tables, like column tables, row table, history table, virtual table. All of them, for all of them, memory is the primary way to access data. So column table stores data in memory. Even row stores data in memory. Even history stores data in memory. But virtual table does not store data physically on memory. It is nothing but the cache memory. So smart data access uses cache memory. So what is the difference between a physical memory and a cache memory? Cache means temporary area. Physical means permanent. Until the power is there to supply to memory, you can physically store data. That is how HANA is designed to store data physically on memory. until we supply power to memory. If the power is lost, the data is lost. But in memory, we also store data in runtime. We can store data in runtime. So to store data in runtime, we use virtual tables. In virtual tables, using virtual tables, we access data from non-SAP systems. Means we physically does not have to load data. Like how we load data to SLT, physically we load using BODS or using DXC. We actually, it occupies space in memory. But here, the data is only accessed in runtime. Only at the execution time of the query, it goes to the source system access data. So if you go to so once we create this connection, then if you go to the catalog, excuse me, if you go to the schema called West, right click on the tables, here you see the new virtual table. Then you see a new table. When you create a new table, let's say when you create a new table, you can create row store, you can create column store, you can create table types, the runtime information, total memory consumption. This is physically storing data. Now, when I right click on create a new virtual table, you see there is here this is the column table and this is the virtual table. There is a green color pipe under the table. So here it is asking us, it asks us to which remote object you want to connect. Means to which source system you want to connect. Remote source system. So this remote object is nothing but the smart data connection. This remote object is nothing but the smart data connection. So where do we create connection? At the remote source. So here is the first step. So this is the step number 1. Once we create this, we access this connection inside the remote object. When you click on browse, so here it shows you the connection. You can choose once you create the connection, you can choose what table you want to choose. You can select. Once you select, it inherits the structure of the source system. So whatever the table it is on the source system, it basically gets the structure and creates a virtual table. This virtual table we consume in the calculation views. So you can combine virtual table with a column table. You can join. You can write different conditions. So the only difference between a column table and a virtual table is both of them use memory, but column table physically store data, virtual table access data in the runtime. That's why it is called as virtual table. And table which only access data in runtime. A virtual table doesn't store data. It accesses data in runtime from source system at the time of the user query. But let's say in the non-SAP system, we're accessing a table. So whatever the data that you have, it basically keeps the data in here, but it keeps data. It doesn't store physically, but it has a capability to store data for a certain amount of time. So when the user requests, it fetches data. If any new records are requested by the user which are not available over here, automatically it gets the data from the source system. So this is to avoid the latency of the connection between HANA and the source system. So every time it is accessing from the source, it's actually consuming a lot of time because it has to go to a different system and access. Always if you have in the same system, it is faster. So SAP does remote caching. It does caching. It can cache for some amount of time. It keeps data for some amount of time. If the data is not available over here, it goes to the source system and accesses the data. So let's go back to HANA. So we give the name for the remote source. So we know, right? So when you right click and new remote source, let's give the server name. I'm connecting to HANA again. Port number, username, password, and click execute. So this connection is created by HANA admin. So once the HANA admin creates a connection, click execute. Remote source created, connection to remote source established. Right click on the source and click refresh. So this is the new source. So based on this new source, so here we have the virtual table. So how do we create virtual table? Go to the pen. What object you want to select. So there is a schema called S-Flight. So in this you have few tables over here. So I'll select the table called S and Let me check. We'll take a SE plane and click OK. I'm selecting this table and click OK. So this is the structure we got from this. The table is created. So this is the name of the table. So it is source underscore SS1. I click on tables refresh. Source new source underscore SS1 underscore SE plane. I click on the table and open data preview. So when I open data preview, you see it's showing the data, MNDT, plane type, maximum cargo, and the kg, the unit for the cargo. So when I execute the query for the first time, it took 31 milliseconds. Now when I refresh again, it takes 16 milliseconds. The reason is for the first time it has to basically go to the source and fetch. The second time, because the data is already in memory, the table has data in the memory. It does caching of data. So it can access data from the cache memory rather than going to the table from the source. That's why it is faster. So once this table is created, we can use this table I'll close the catalog. I'll expand the content. Under the content, creating a package called Smart Data Access. Click OK. Click OK. Right click on the package, new, click on the calculation view. Give the name, provide the name. View type calculation view. Data category cube and click finish. Once you click finish, and click on the projection, click on the work area, click on add objects, give the object name, select this object and click OK. So when I right click on the package again, click New, click on the analytic view, also creating an analytic view. In the analytic view, now we're in the analytic view now. There's the data foundation. I give the table name, select the table, click OK. So you get a message over here. For virtual table support, a calculation view must be created. Do you want to copy this view as a calculation view? So analytic views are not supported for the virtual tables. We can only create calculation views. Yes, I want to show this message. So click No. I'll close this. So virtual table, we can only create calculation view. You can select the required columns. Click on Join. Link projection to join. The join. I'll select any table from, select a table from HANA, plain type. So we select another table. So we'll join plain type with plain type. Maximum cargo unit price. I'll select as inner join. Maximum seats. Connection ID. So once we give the join condition, I'll say join one to aggregation. I'll select the aggregation. So select the required columns to the output. Click on semantics. Click on auto layout. Connection ID. Let's click validate and click save and activate. Let us assign to request. Click finish. Let us go to the package. Expand the package. So there is an error. Let's see what's the error. Encountered an error in the runtime repository. Mod inconsistent. Create scenario failed. User not authorized. So we are not authorized to the schema. So we're not authorized to the schema. Yes, flight. So in order to get authorization for a flight, I'll just go to security. I'll go to the catalog. I'll go to the security. Go to users. Double click on the user. Double click on the user. And the object privilege. Actually, I haven't started with the privileges yet. Once we actually start, I think you'll be able to resolve this issue. So we need to basically click on the plus icon. A flight. What's the table? You can actually take a table, a flight, but this is from, I think this is from this schema, S flight. From S flight, click OK. You have to have select privilege. You want to insert. And then once you insert, click execute. Once you execute, it changes the user. The user is changed. Once the user change, we can go back to the data model. So this is the schema name. S flight from S flight. Let's go back to content. In the package, calculation view, again validate and activate the view. I think again we have the error. Let's see. What we'll do is we'll also give access to the schema. As given access to the table, we'll give little higher object. We'll give to the let's see if you already have this. Just give me 1 second, please. Just trying to give the ownership. I'll give the ownership and access the view. We will discuss this in future section again, but just I'll complete this. Just give me 1 minute, please. I'll just. So we'll just close everything and reopen again. Sometimes it doesn't refresh. What I'm going to do is I'll just close this. and reopen again. So anytime if you think that whatever you're doing correct, the system is unable to show. For example, this you can try to close and reopen the HANA Studio again. The projection node. And we only have the best. Only we're accessing data from best schema. Click on the aggregation. Select all columns to output. Click on the semantics, add all, validate, and save and activate. Just a simple table you're accessing. And click finish. Now in this case it is completed successfully. So we're able to access data from the virtual table. But what is happening here is we're trying to access data. So we're accessing on the best schema. On the best schema, the system has access. System user has access on the best schema. But now when we add this table, I'm creating a join now. So click on the join and take the projection as input to the join. I'm going to add a new table. Now the table I'm adding is from S-Flights schema. So S-Flight is in different schemas over here. I'm taking from this schema, which I don't have authorization. So we have SAP ABAP 1, which is the same table. Now if I take from this schema, SAP ABAP 1, I can get activated on this table if I basically again join on plain type and plain type and access to join one to aggregation. Now when I validate and activate, and validate and activate the data model. Now we are activating on the system user. You see the things I'm doing on the system user. I can activate this. The reason is I have for system user the access to SAP ABAP 1 schema. Table is same, but the schema is different. So now I'll replace with the data source. Nothing but from a different schema. Now S-Flight from S-Flight schema. Click next. It's asking what you want to replace. I want to replace with F-Flight with F-Flight schema. Click Next and click Finish. Once we finish, now it is replaced. Previously we accessed from ABAP 1. Now previously we don't have access, so we have given access. Validate. It's throwing an error because this schema does not have access to system. Because this schema is actually created on the schema I created when some of the participants created F-Flight using this user, not from the system user. So that's why it is throwing this error. So we need to give grant privilege on the schema. So once you provide this privilege, so for this reason what we have done is, we went to the security, we went to the users, went to the best user. In here we already have access to, in the object privilege, we already have access to F-Flights. You see here, we have access to F-Flight. So privilege on F-Flight, we have access to everything. But now I'll go to the system user. I'll go to the system user. In the system user, let's click on the object privilege. So let's search for F-Flight. You see, we don't have the select privilege on the table. That's why we're not able to access the table using the system user. So that's the issue. So today's topic, I started with the Smart Data Access. Smart Data Access is used to access data from non-SAP systems, like SLT for real time, BODS for batch, DXC to access data from existing BW systems. Using Smart Data Access, we can access data from non-SAP systems. We can connect to different non-SAP systems like MS SQL, Sybase, Oracle, DB2, any of the relational RDBMS or file systems like Hadoop. We need to create an ODBC connection. Once the connection is created, we can create a virtual table in the schema. Virtual tables are those tables which can access data in runtime. They don't physically store data. When creating a virtual table, we need to specify from which connection are we trying to access the table. We select the table. It inherits the structure from the source, but it never stores data. Virtual table access data at the time of the user query. First time when you execute the query, it goes to the source and fetch data. But from the next time when you access the table, these tables are very fast because already they are storing in the cache memory. Only for the new data, for the existing data they get from the cache memory. For the new data, they go to the source, they go to the source system and fetch data only for the new data. So this is to minimize the latency between source and target. So what is the major advantage of using Smart Data Access is, The major advantage of using Smart Data Access is we don't have to buy additional products like BODS without using an ETL tool. Without even using an ETL tool, just by a connection, we can access tables from source system. Only creating a simple connection. That's why it is known as Smart Data Access data. You don't have to buy any tool, just a connection, you can get data from the different source systems. And a HANA consultant can directly do this. Again, we don't need a separate consultant who has BODS knowledge. And once you get these tables, you have one more option called Smart Data Quality. You can transform data. Like how in BODS we can transform data. Even in Smart Data Access, we can transform data. You can apply different transformation rules for the Smart Data Access. There are predefined transformations that SAP has given inside the HANA DB. So using those transformations, you can apply transformations on the virtual tables. Or you can create business logic based on the virtual tables when creating data models. You can join, you can do union. All the operations further you can perform in the calculation view. Any questions on Smart Data Access, please ask me. Before we go to the next topic, which is SAP HANA Live. I'll just give an introduction to HANA Live. So here we have a question. Do we have to definitely create a virtual table So next question, Smart Data Access is for non-SAP system. Then we just access from another HANA DB. So you see the percentage of access like Oracle, MS SQL, DB2, Hadoop, all these are non-SAP systems. So we're basically talking about the percentage of access. So HANA, we can also access from HANA. So that's a different story. But the major Just got disconnected. Connected again. So lead questions over here. So when will we go for smart data access? The smart data access, you can go when you want to create a data warehousing solution. You want to instantly access tables from the source system, from the non-SAP system, without requiring any additional tools. Directly creating a connection to the source system, you can access data. So next question. In DXC, what is the purpose of T code RSDS? RSDS is a T code to replicate data sources. In order to replicate data source, we use RSDS. Next question. In HANA, since all data is stored in memory, once the power is off, all data is lost. So once the power is restored, you need to bring all data back. You need to bring all the data from the source in real time. So even we do not run such a situation, okay. So basically when the power is off, all the data in the memory is wiped away. Once the power is on again, the system is restored to the state before the power. So what's the state of the system when the power was there? A copy of data for any transaction that we make in memory is also stored in disk. That is known as a persistency layer. So whenever you insert data into the memory, at the same time, the record is also stored in disk, in the persistency layer. And only then it displays to the user the transaction is complete. For example, we are creating a sales order. A record is inserted on both the places, one at the memory and the other one at the persistence area, called a logging area. A logging area takes all the logs of the transactions happening in memory. So once the power is lost, again it restores with a combination of data and log area in the persistence layer to the current state of the database. So using something called lazy loading. What is lazy loading? Suppose say you have 10 TB of data. The entire 10 TB of data cannot be into the memory because the bottleneck of the disk can revolve at certain speed. Disk can revolve at a certain speed. The speed at which the disk, if you take a normal disk, it takes 5,200 RPM at the least. Then you have 7,000 plus RPM. Then you have little faster disk, 20,000 RPM. Then you have more faster disk like SSD, which is not equal to memory, but still they are faster than disk, solid state drives. So disk is SSD faster, from SSD faster, memory is faster. So 10 TB of data you want to load at a single shot to memory. It is not possible because of the bottleneck we have on the solid state drives or on the memory. So what system does is lazy loading. does load data lazy, means it takes priority. What is the data I need to load to memory once the database is restarted? What's the priority I have to take? So based on the priority, how does system know what's the priority? The system knows the priority based on the check marks that we make at the configuration. HANA admin basically checks the tables that needs to be loaded into memory first, after the database has been restarted. Obviously, after the database is restarted, first we require system tables. So all the system tables are loaded. So once it loads the system tables, database is up. Once the database is up, then how does system take priority now? Basically based on two things. The first thing is, when you file a query by a user, at the same time, you can access data from disk into the memory. So you're basically accessing data from disk for the first time after the database is restarted. So obviously, the query is going to take some time. The first time we're accessing data. So from memory to the disk, the data is loaded. But how much data is loaded? Is the entire data of the tables are loaded, or only partially data is loaded? Only the partial data is loaded, because when user query, he may take some criteria, date from, date to, only for certain date range, or for certain company codes, or for certain sales organizations. Now, based on that criteria, the data is loaded to memory, means partial data is loaded. Still the other data is still available on the disk. And now, system checks, okay, is this data recently added? By using lazy loading, it loads data back from disk to memory. So simply to say that the power is off, data is obviously lost, but it does not happen because you see, when we invest so many millions of rupees in buying HANA, obviously you have backup. Nothing but a simple UPS, uninterrupted power supply. Even the power is lost, you have an UPS which can take care. Even most of the houses now have UPS. Just for our personal use, think about data centers and the backup they have. Okay, let's say the UPS is, you see, yeah, UPS is not working, for example. There may be case UPS is failed. Obviously, when UPS is failed, there is no power. Let's think a scenario. When the UPS is failed, the power is lost. If the power is lost, data is lost. If data is lost, data is there on disk. Let's say UPS, the power is lost, so you can get data from disk to memory. There could be a scenario also, memory is lost, means memory is not working. There are a lot of scenarios when memory is not working. Slave. Slave is waiting for the master to fail.
it is waiting. When the master will fail, I will take over. This is known as high availability. In a high availability scenario, the slave is waiting. When the master will fail, I will take over the master. It uses heartbeats. It means that when the master fails, slave sends heartbeats to the master. It sends 10 beats to check whether the master is working. If the master is failed, slave is out. Now, for example, let's say the master and slave also is failed. Let's say our time is very bad. Master is failed, slave is failed. Total data center got collapsed due to the natural calamity. Frequent earthquake occurred. The data center is completely broken down. For example, let's say in a scenario, even if the data center is completely broke down, we have another data center set up in a different geographical location. A data center in Japan is collapsed. We have another data center in India. Which parallelly replicates data from one data center to another data center using hot sync. They use something called hot sync to maintain the data in two different data centers. If one data center fails, immediately the other data center is up. And the business is not even aware that this is all happening in the back end. What all the business can say is systems are running as it is with no interruption, with high availability. So all this is designed in the service level agreement. When a hardware or the customer signs up a contract and providing the consulting services, all this is set up in the SLA. How much time system should be up for any issue? Whether it could be a data issue, whether it could be a hardware issue, whether it could be any kind of issue, there is a time that is allocated for the system to be up and running in the service level agreement. So based on the priority, the consulting team executes the tasks at the highest priority, taking the business operations into consideration. So there is nowhere HANA is high availability, disaster recovery. Anything happens to the system, immediately there is a backup which can handle until the data center. You know, the simple thing is in Gmail we have everyday access emails. So one email of ours is stored in 7 different data centers in geographical location. Google has different data centers across the globe. One email of ours is stored in 7 different geographical locations. Think about an email of us is taken care by Google. How important is the business data? That's why HANA is expensive. It is still expensive for the initial setup. But once it is established, the maintenance cost is very less. Maintain it is very less, but the initial investment that you have to make is more. The other side of the relational RDBMS. Relational RDBMS are, to buy it is cheaper, but to maintain it is expensive. We have to basically invest a lot of money in doing performance optimization. Every day we have to dedicate a lot of man hours to do optimization of the system, create indexing, create aggregates. create redundant tables, maintain them. One system for OLTP, another system for OLAP, perform ETL on daily basis, check the jobs, do the reconciliation, a lot of issues. So that is the reason HANA is in-memory, columnar, parallel processing, OLTP, OLAP, high availability disaster recovery, can process semi-structured, structured, unstructured, any kind of data, can integrate with non-SAP systems, can get data in real time, can have geospatial analysis. So any kind of data can be processed with any kind of engine, with any platform. It can integrate with Java, JavaScript, HTML5. Natively, you have an application server. It can integrate with any application. One for all solution is HANA. Yes, there are certain things that HANA cannot do. That is processing of photos and videos that Hadoop can do that HANA cannot do. That is the only disadvantage HANA has, processing of videos and photos. I think that also will get into future. But for now, in order to process such kind of data, SAP has a solution called HANA Vora, which can natively integrate with Hadoop. Okay, so we go to the next question. So HANA is actually, see, everything is taken care by SAP. Memory, disk, hardware failure, data center failure, everything is configured. It's a very robust solution. Next question is, can we access CSV or Excel files with Smart Data Access? We can directly connect to an ODBC connection to the source. We cannot access Smart Data Access. Using Smart Data Access, we cannot access CSV files. Unless and until we integrate with the Smart Data Quality. If you integrate with Smart Data Quality, then you can access from CSV files. And these are the questions we have in the text in the chat box. Tomorrow we can start with a new topic, which is SAP HANA Live, which is ECC powered by HANA, or the sidecar scenario. You can see in tomorrow's session. Thank you everyone to attend today's session. We'll see you tomorrow, same time. Thank you. Have a good morning and good night to everyone.